This is a good example of an opportunity we have to either make two substitutions or choose a bigger u, because when you get to the second line here, we still can't integrate. So now you have a choice. You either can substitute again, we talked about this in class, let's choose a new variable w, let w be the sine of u, then dw will be the cosine of u du. So here we have a w and a dw, which makes this integral 3 times the integral of w to the 5th times dw. That's a very easy antiderivative. 3 times w to the 6th divided by 6. 3 divided by 6 is 1/2. W is worth the sine of u to the 6th, but we need to go all the way back to original variable. So 1/2 the sine of the original variable, 1/3 x for u, all that stuff raised to the 6th, which probably we slip the 6 in and make it 1/2 the sine to the 6th of 1/3 of x plus c. If you don't want to make a double substitution here, from the original integral, we can just choose a larger value for the u, namely those two substitutions we did before at one time. That means that, well, let's let u be not just 1/3 of x, but the sine of 1/3 of x. Then du, the derivative of sine is the cosine, argument stays the same, and the derivative of 1/3 of x is 1/3 times dx. So this matches pretty well with the integrand. If sine of x over 3 is u, and then we have an extra cosine of x over 3 dx, that's this part right here. We already have that. So this means that all this green bits are equal to the cosine of x over 3 times dx is equal to 3 times du by moving the 1/3 over. So that transforms the integral only one time. Do we need to make the substitution? We get a u to the 5th times cosine x dx, which is worth 3 du's. And from here we can integrate. 3 comes out, u goes up to the 6th power and divide by 6. You see we have the same thing we had before, 1/2 u to the 6th, but there's only one substitution. U's worth sine of 1/3 x, so this is 1/2 sine to the 6th of 1/3 of x, or x over 3, plus c. Same answer, just a matter of how we work it out.